So good afternoon, everybody. Today, me and my colleague Mohammed are going to talk to you about some of the research and development activities that are going on at UK NEQUEST for microbiology. So I'm going to chat to you a bit about the hepatitis E detection scheme, and my colleague is going to talk to you about the development of a new EQA looking at the detection of carbapenemase producing organisms. So first, I'm going to chat to you about the hepatitis E detection scheme, which is a UK NEQUEST for microbiology first, in the terms that it is the first scheme to known knowledge that has merged a serology scheme and a molecular detection scheme within one EQA. So just to give you a bit of background on hepatitis E, it's an RNA virus which is transmitted through the fecal oral route via contaminated drinking water that causes inflammation of the liver. An acute hepatitis E infection can be detected by the presence of hepatitis E RNA in blood and stool, or immunoglobulin M antibodies in blood. So you can see here from figure 1 that between 3 to 6 weeks post-infection, HEV RNA is present in the blood. This is then followed by an increase in IgM antibodies at about 4 weeks post-infection, and then it's followed up by about at 5 weeks post-infection with an increase in IgG antibodies. So we had 2 schemes that captured the testing of hepatitis E, a serology scheme and a molecular detection scheme. So you can see here that table 1 summarises the serology and molecular detection schemes that we had. And you can see that there's some similarities in the terms of they were both introduced in 2018, and there's both 3 distributions per financial year. However, there are some differences, being that the serology scheme, there is 4 samples that are sent out per distribution. And these are serum samples that are used to detect IgM and IgG antibodies using a variety of different immunosorbent assays and line assays, for example. Whereas the molecular detection scheme, there's 2 samples sent out per distribution, and these are freeze-dried plasma samples, which are used to detect RNA using a variety of different nucleic acid techniques, including PCR. And you can see on the right-hand side, the number of participants that are registered for the hepatitis E serology scheme, molecular detection scheme, or both schemes. And you can see that there's quite a large percentage of participants that are registered for both. So knowing that we've got quite a large proportion of participants that are registered for both the serology and molecular detection schemes, and we know that from the UK Standards for Microbiology Investigation report that hepatitis E antibodies and RNA should be detectable in serum, could we potentially merge these schemes into one EQA that participants could register for that would detect both antibodies and RNA? So there was a lot of different factors that we needed to consider in order to proceed with this. And one of the main factors is the fact that we've got quite a large percentage of participants that are registered for both the serology schemes and the molecular detection schemes. So you can see here that 43% of the serology participants reside outside of the UK, and 53% of the molecular detection participants reside out of the UK. So these are quite large percentages. And we know that from the serology schemes, that antibody degradation doesn't happen to such an extent that if we send out a positive specimen for an antibody, that we know that yourselves can provide the intended results for that. Whereas we aren't sure about that for RNA, as we've never sent out RNA in a liquid serum format before. It's always been freeze-dried plasma. So that provided me with a research objective, which is to determine the stability of hepatitis E RNA at room temperature over a typical dispatch period. So the project plan was to take 8 samples of known IgM, IgG, and RNA content, and table 2 shows you a summary of the sample profiles used. So we've got sample 1 and sample 2, which are IgG positive, so no RNA should be detected in those samples. Samples 3 and 4, which were RNA positive only samples, and samples 5 to 8, which were positive for both IgM and RNA. And 8 aliquots from each of these 8 samples were taken and placed at room temperature. And for each week of testing, one of the 8 aliquots from each sample was split into 2, and these duplicates were extracted and then ran on PCR. So testing continued over a 6-week period to reflect a typical dispatch and distribution period. So this 6 weeks encompasses the amount of time it takes us to dispense the samples, the amount of time it takes us to pack these samples ready for you, and the amount of time that we provide yourselves to report on the samples. So just to give you a bit of a process overview, we've got 8 samples which we split into 2 duplicates, extracted those, ran them on PCR, and that was completed 6 times. So table 3 just shows you a summary of the CT values obtained over the 6-week testing period. We're looking at specifically CT values, as the molecular detection scheme is only a qualitative scheme, so we're not looking at any viral concentration units there. So you can see at the top of the table, you've got week 1 to 6, and down the side of the table, you've got the samples. So samples 1 and 2, which were IgG positive, provided the intended results as there was no RNA detected over the 6-week period. Samples 3 and 4 were RNA positive only samples. So sample 3, you can see that there are some extracts that we ran that no CT value was provided, so virus wasn't detected. However, sample 3 is a very borderline specimen. So it did actually contain a concentration of hepatitis E that was below the limit of detection for our kit. So it is actually quite promising to see that even up until a 6-week period, it still did manage to detect RNA, even if it was a sample that was below our limit of detection. And sample 4, again, provided us with CT values all the way up until a 6-week period. And then samples 5 to 8, which were IgM and RNA positive samples, provided us with CT values again for these different RNAs all the way up until the 6-week period. So this is really promising to see that the RNA is stable in a liquid serum format all the way up until 6 weeks at room temperature. It was also really positive to see that the average standard deviation of these CT values were quite low, which indicates to us that it should be a reproducible result. So, as I said, the PCR results looked really promising, so planning to merge the serology and molecular detection scheme could start. A questionnaire was sent out to all the hepatitis C molecular detection participants to ask whether a liquid serum format would meet the requirements of the platforms that they use to detect hepatitis C. And figure 4 just shows you the questionnaire that was sent out to all participants, which asked questions such as what assays were they using, what types of sample were suitable for their platforms, and what kind of sample volumes they needed from us. We also offered to send out samples of known HEV RNA content to participants if they requested that, in order for them to test it on their platforms to just double check that the serum was compatible with their platforms. And the results of the survey didn't indicate that there'd be any issues with testing liquid serum for RNA. However, it is worth noting that we only did get 5 responses from that questionnaire. So just to summarise, as of next month in the new financial year, UK NEQUAS for Microbiology will be offering the Hepatitis E Detection EQA scheme, which will allow participants to report on IgM, IgG and RNA all within one EQA. And just to let you know, we are aware that there are participants that only registered for the serology scheme or were only registered for the molecular detection scheme. And that's absolutely fine. There's no requirement for you to report on both of these markers. If you were only testing for antibody detection, you only report for antibody detection, and likewise with RNA. So I just want to say thank you to the UK NEQUAS for Microbiology team for their support with testing and the implementation of this scheme, for NHSBT for providing the hepatitis C samples that we process and use in our schemes, and also the Wolfson EQA software for their ongoing support with the delivery of our EQAs. So thank you very much for listening. And are we going to go for questions now, or would you like to carry on and go into the carbapenemase?
I think it might be better to take the question at the end.
Okay, no problem.
Yeah.
Okay, so I'll pass over to my colleague Mohammed.
Okay, hi. Can everyone just hear me?
Yes, we can.
Yes, we can, yeah.
Hi, I'm Mohammed, and I'll be giving you a presentation about the development of an EQA scheme for the detection of carbapenemase-producing organisms. So this is a schematic of the steps required in the development of a new scheme. First, we have to justify an EQA is relevant to clinical needs, and there's a gap in our schemes where we feel testing should cover. A questionnaire is then sent out to determine whether labs may be interested in this scheme. Specimens are then designed, and stability, homogeneity, and viability testing is carried out to ensure that specimens are able to produce our expected results, and there is no degradation in the sample before it reaches participants. Pilot studies are then carried out with interested labs to see if we're able to deliver the scheme to participants. The results from the pilot distributions are then analyzed for evidence to support the delivery of the EQA. And if all goes as expected, then the distribution is able to proceed to a live scheme. I am now going to go through each of these stages in more detail in relation to our new EQA scheme for the detection of CPO. Carbapenemase-producing organisms are multi-drug resistant bacteria which have emerged through increased and often inappropriate usage of carbapenems. Carbapenems are broad-spectrum beta-lactam antimicrobial, frequently used as a last resort for treating life-threatening nosocomial infections. And CPOs hydrolyze carbapenems via the production of the enzyme carbapenemase, causing drug treatment to become ineffective. In 2017, the World Health Organization published the first ever list of priority pathogens, which considered carbapenem-resistant Acinetobacter baumannii, Pseudomonas aeruginosa, and Enterobacterales priority 1 critical organisms for urgent need of new antimicrobial agents. Due to their ability to readily spread and colonize patients in healthcare environments, preventing the transmission of these organisms is a major public health initiative. There were 2,183 reports of acquired carbapenemase-producing gram-negative bacteria in the UK population from October 2020 to September 2021. Therefore, there is a warranted interest for an external quality assessment scheme to assess the performance of labs providing a service in the detection of the genes that cause the big 5 CPOs, which are VIM, NDM, KPC, OXA48-like, and IMP. These are most prevalent in the UK, so these will be the 5 genes the distribution will be targeting. A questionnaire was sent out to participants of the antimicrobial susceptibility scheme and the community medicine scheme in 2017 to identify if labs currently screen for CPO, what screening methodologies and genotypic testing labs carry out, and if they would be interested in participating in a pilot study. Results from the questionnaire identified that labs are now in favor of using chromogenic agar compared to traditional methods such as overnight TSP incubation or non-specific media to culture and identify any potential CPOs. For genotypic testing, the results showed that molecular method was the most common form of genotypic testing compared to immunochromatographic assays. And 327 labs expressed an interest in the pilot distribution, which confirmed that there is a strong need for this EQA. So then a primary study was then designed and set up, which included 6 specimens, where each specimen was positive for one of the big 5 CPOs, and a negative specimen was also included. There was also 4 different sample mediums tested, which included a lyophilized sample, which is a traditional method used by UK Nuclear for microbiology for bacteriology schemes, as well as 3 swab types of a liquid AMI swab, fecal trans swab, and a dry swab in brain heart infusion broth. Each subtype contained a different growth medium to ensure organism viability while replicating patient samples. The same bulk material was used for each medium type to maintain consistency. A second study was then carried out on 6 specimens. Again, the 5 big CPOs and a negative specimen was selected. In this study, commensal organisms were also included in the bulk material to replicate a more authentic sample that labs will be expected to see when testing patient samples. This study was carried out on the liquid amine swab sample type only, as this was shown to be the most viable swab type from the primary study, which I will show you the results for in a later slide. Stability, homogeneity, and viability testing was carried out on the specimen for each of the studies to ensure that specimens were able to maintain the stability from the time they will be made to transport and storage conditions, to ensure there is no degradation of sample quality between each testing lab. Each study lasted for 8 weeks, where testing was carried out at 10 different time points at 24 hours, 48 hours, week 1, all the way to week 8 post dispensing, to ensure viability of specimens for this time frame, as some of our samples are prepared a month or 2 prior to dispatch to labs. Specimens were also created in duplicate, where one set of samples was kept in ambient condition and one set was kept in 4 degrees. This was to determine which temperature and conditions will be best for specimens to be stored at. The testing involved subbing each sample medium onto a blood agar plate, a McConkey plate, and a chromogenic agar at each time point, which was then incubated for 24 hours, where yield of growth and colony morphology was then recorded throughout the weeks of testing. Using the organism grown from the chromogenic agar, genotypic testing was carried out using the NG test Carbo5, as this was shown to be commonly used by responses returned from the initial questionnaire. So these are images of three of the organisms selected for the specimen material, which show growth and morphology of colonies. These plates provided the source material for which the individual specimens were made. ID and genotypic testing was carried out to ensure there's no contamination. Image A is of Klebsiella pneumoniae, and image B is of Acinetobacter pneumoniae. This was a negative specimen. However, it was able to grow on a chromogenic media. Upon further genotypic testing using the Carbo5, that it did produce the negative result, which is what we was expecting. This shows that the importance of carrying out genotypic testing, even if it does grow on chromogenic media. And image C is of Pseudomonas aeruginosa. So this image shows the results of our genotypic testing using the Carbo5 assay. This was a popular method used by participants from the questionnaire responses, so was selected to be used in our stability studies. The genotypic result is the vital piece of information when reporting the CPO in patient samples. So it's important to get this correct and give the correct interpretation. This table shows the results recorded from the stability testing of the first study. It is to be noted that the results for the fecal transwab are not included. This is because testing on the swab type was carried out for 2 weeks only due to the unavailability of the swab type. We can see from our results, all sample types produced our expected and consistent results throughout the 8 weeks period and was able to correctly identify the target gene up to 8 weeks post the sample being prepared. However, the swabs stored at 4 degrees demonstrated reduced organism yield of growth of test organism, which was displayed on the dry swab containing PHE broth, where after 8 weeks, no growth was observed on the culture medium. However, for the lyophilized and liquid amine transwab, there was no sample degradation after 8 weeks. This led to the liquid amines being chosen as the potential swab medium type during pilot testing, and showed that a swab medium can produce comparable results to lyophilized samples. Regarding the Carbo5 assay, the dry swab demonstrated the least favorable results, as shown with the faint line at 8 weeks at ambient temperature and no growth of the organism at 4 degrees. Following on from our stability testing, 3 pilot distributions were sent out to participants with a total of 6 specimens, so 2 specimens in each pilot. A lyophilized specimen, as well as a simulated rectal swab in the liquid amine swab, was sent in each distribution. The first 2 pilot distributions, 5150 and 5157, only contained the testing organism of the carbapenemase to be identified. However, the pilot 5162 also included commensals within the testing sample. This was done to replicate as much as possible patient samples potentially received by labs. 5150 was sent out in July 2021, 5157 in August 2021, and 5162 was sent out in December 2021. The pilot distribution was sent to 63 labs, and participants were given 3 weeks to return results, and the results were not scored. Of the 63 participants, 47 labs returned results, with 1 lab returned not testing results for the pilot distribution 5150. The results showed that the most common method for genotypic testing was the Cepheid Expert CarboR platform, with 17 participants using this method. The next common testing method was the NG test Carbo 5, followed by the Coleridge Resist and an in-house PCR testing. This showed that there is a wide range of testing methodologies carried out in the various labs, with molecular methods being the most common testing methodology, followed by the use of immunochromatographic tests. This is a summary of the pilot study results, and from the results we can see that stimulated rectal swab type produces comparable results to the live filled vial for all 3 of the pilot distributions. 91 to 96% of participants returned the expected results in the first and third pilot. So this shows it's also promising to see, with the addition of comments within the distribution 5162, the results were comparable between the different sample mediums. You can see the distribution 5157 was correctly reported between 84 to 86%. This is a low percentage. However, upon further investigation, it was noticed that many labs used the same chromogenic agar, who all reported no growth and a negative result. This showed the importance of this EQA to avoid incorrect reporting of patient results. And also for the specimen 7136, false positive results were returned, which could potentially result in the unnecessary use of antibiotics for treatment. This further supports the importance of an EQA to detect the presence of CPOs. So following sending out pilot distributions, returns testing is carried out by UK NICRAS for microbiology on all specimens that are sent out for any scheme. This is where specimens are sent to 4 labs situated in the UK to be sent back to us at NICRAS. Testing is carried out on the specimens once received, and this is to ensure that specimens remain viable during prepping and transporting of samples to lab. This gives us confidence in the homogeneity of samples received by each lab for a particular distribution, as well as to confirm there was no degradation of specimens. Image A is the returns testing plate for stimulated rectal swab sample, and B is the plate for the lyophilized sample. We can see the yield of organism growth is greater in the stimulated rectal swab sample compared to the lyophilized sample. This provides further evidence that not only does the stimulated rectal swab sample produce comparable results to the lyophilized sample, also the sample yield is also greater, meaning greater sample viability in the swab medium. Having carried out the pilot distributions, the detection of carbapenemase organisms has now become a live scheme, which will go live from April 2022, and each distribution will include 2 stimulated rectal specimens in swab format. And the reporting mechanisms will be identifying the organism, if there was any present, and the resistant mechanisms, if it was present or not present, as well as the carbapenemase that was present that is to be reported. So there will be 4 distributions per year, and the first planned distribution is in May. And you can still visit our website to register for the scheme. Also, this is also a first for bacteriology and UK NICRAS, as the sample swab will be sent in a swab format as opposed to our traditional method of the lyophilized sample. So this is an exciting time for us in the scheme. I would like to thank all the team at UK NICRAS for microbiology for the excellent work in the development of the EQA, in the detection of CPOs in clinical specimens, and thank you also to the laboratories that provided feedback from the questionnaire sent in 2017, and the laboratories that participate in the pilot distribution. I would like to just leave you with our flyer, with our promotional material for this new EQA. And if there are any questions, please type them in the chat. That's me finished.
Thank you, Mohammed. Thank you, Heather. They were two brilliant presentations. We do still have quite a bit of time before the end of the session, so if you do think of any Q&As, feel free to pop them in. So there is a question for Mohammed in the chat. I see he's just took his headphones off. Can you still hear us?
Oh yes, it's because Heather's in the room with me as well, so we can hear both questions if it's fine.
Perfect. Just wanted to check.
Yep.
So the first question is, what chromogenic agar did we use in our testing?
So we used the ENO chromogenic agar, the MS supercarba. So that was a chromogenic agar we used, and that was used to identify if the growth of the organism on the plate, and during the whole study it was also used.
Thank you. Oh, the questions are coming in now. Brilliant. My lab would be testing the CPO EQA on both media and expert Carber R. Would it be okay to process via both methods using one swab?
Yes, this should be fine, because the reporting options for this scheme will be the ID of the organism. So if you manage to grow anything, what the organism was, and the reporting option of the carbapenemate that is present in the sample. And so this should be able to be carried out on the various methods. However, it is the genotypic testing result for the carbapenemate is the important aspect of this scheme.
And it's just important to note as well for participants, I know some go straight to molecular and they might not identify the actual organism itself. So if that's the case, just put not examined for any of the parameters you don't test against. Next question again for Mohammed. Rectal swabs stored upon receipt. So what temperature?
So our stability testing carried out testing at both temperatures, at ambient temperatures and 4 degrees. And we managed to see that the sample stays stable in both temperatures. So whether it's kept in ambient temperature or plus 4 degrees, you should still be able to, it should still produce the same yield of growth, regardless of what temperature it's stored at once received in the lab.
Yep, thank you. Does NG Carber 5 used for Acinetobacter species? So we use the NG Carber 5 for our testing, didn't we? So can you use Acinetobacter for that kit?
So in our testing, we had the Acinetobacter as the negative specimen, and from the images I showed earlier, it did grow on our chromogenic agar. However, it was negative. But when we did do a Carber 5 test on it, it did produce a negative result. So although the plate was positive, the vital information of the carbapenemate present was negative. So that gave us the right result.
Next question again for Mohammed. We have a screening method only, so that they use chromogenic agar for their screening method for CPE. However, when we send the isolate for confirmation to RefLab after initial sensitivities on site, how should we report the results?
I'm not sure how long, maybe Jenny will be able to answer, how long it needs to be reported by to return the results. So if you get the results from the reference lab before the scheme closes, you should be able to still put in your information of your in-house testing as well as the reference results, the reference lab results, as that's what you would be giving the patient sample.
But we do say if you don't test in-house and you send to a reference laboratory to report as not examined. So I'm not sure how you would report for this scheme, because so you'd be identifying it and you would be reporting out more of a presumptive CPE rather than doing the actual testing yourself. So maybe that's something we need to take into account if many labs are still doing that. Okay, next question from Natalie. I have heard the NHS labs aren't sending any CPE isolates for confirmation. Instead, they do broth testing. Is this correct? So it's, It's not something I've heard. I know NHS labs are not sending samples to the reference lab anymore because the reference lab have said we should be confirming it in-house ourselves now, but I'm not sure about this broth testing. Maybe could you email me and I can get a bit more information about that? And then we've got another, well, more of a comment. We report presumptive only. Thank you, Natalie, you will get in touch. And that appears to be the end of the Q&A. I don't know, Sanjeev, Marit, do you have any questions for Heather?
Well, I don't think we have question for her, but I think the research work that she's carried out has shown to us that it is possible to have one type of matrix for all the HEV markers. And I think it's an exciting time for us because it's something that will guide us in the future in terms of our specimen preparation. And I would like to take this opportunity to thank Heather for the excellent work she's done on this project.
Thank you, Sanjeev.
Yeah, I would add that as this is a bit of a pilot for us, and if this is very successful, then in the future it will give us an opportunity to maybe do more schemes where both serology and molecular results are reported within one EQA. So we are very eagerly anticipating to see how this EQA is accepted, and it might lead to new developments for other schemes as well. And thank you, Heather.